Let's go.
Hello everyone, you are welcome to my channel. Here is 2023 NECO Physics Past Question Solution Series. We are still in objective, question 31 to 35. So if you have been following us, we have done up to question 30. So today we are going to look at question 31. Question 31 says, the attraction experienced by objects on Earth's surface is due to what? A. Acceleration due to gravity. B. Centripetal force. C. Electrical force. D. Gravitational force. E. Magnetic pull. The correct answer here is gravitational force. Option D. Question 32 says, calculate the force of attraction between two particles, each of mass 2 times 10 raised to the power minus 2 kg, separated by a distance of 10 by minus 10 meter, given that G is 6.7 times 10 raised to the power minus 11 Newton meter square per kilogram squared. So if you remember the universal gravitational law, so that's what you're going to use to solve this. Remember, the force of attraction F is equal to G m1 m2 all over r squared. Are we together? And here we are given that said two particles each of mass 2 times 10 raised to the power minus 2 kg. It implies that the mass 1, the first particle, has mass 10 raised to the power 2 times 10 raised to the power minus 2 kilogram, and the second particle has the same mass, which is 2 times 10 raised to the power minus 2 kg. It's as simple as this, very straightforward, right? So also we are given that gravitational constant G, if you are not given, you should know it is 6.7 times 6.67. Here they give it to be 6.7, so let us use 6.7. But the number is 6.67 times 10 raised to the power minus 11 Newton meter squared kilogram per kilogram squared, and the distance r is given to be 10 raised to the power minus 10 meter. So now substitute this value into your formula. F equal to G m1 m2 all over r squared. So that will be equal to, what is G? 6.7 times 10 raised to the power minus 11. I told you it's 6.67, but what we are giving here is 6.7, so let us use it like that. Then multiply by m1 is 2 times 10 raised to the power minus 2, m2 2 times 10 raised to the power minus 2, everything divided by r, which is 10 raised to the power minus 10, and it is squared. I'll square it. So when you press your calculator, you multiply the whole of the numerator, you should have your answer to be 2.68 times 10 raised to the power minus 14 all over 10 by minus 10 squared to give us 1 times 10 raised to the power minus 20. So when you divide the numerator by denominator, you should have 2.68 times 10 raised to the power 6 Newton. So are we together? So this is how to tackle this type of question, and from here the correct answer should be option what? Option C, 2.68, but I'm seeing minus 44, but I am sure the correct answer is C, 2.68 times 10 raised to the power 6 watt. So I'm convinced the answer is raised to the power 6, right? So that is about that one. So let's move to question 33. So question 33 says, which of the following is correct about electric line of force? Electric line of force, right? So remember, electric line of force, they are imaginary line that we use to detect the direction of the electric field, right? So A, they are far apart in a strong field. That is wrong. So from here, the question is asking you to look for the correct. So you just pinpoint the wrong one, then you look for the correct one. So for electric line force, they are strong when they are relatively close together. So we have a very strong feed here compared to if we have this like this. So the feed is weak here compared to this one. So the option A is wrong, right? Now you're looking for the correct one. Option B says they are not continuous in any region. They are continuous. So it's also wrong. Option C, cross one another. They do not cross one another. Cannot have feed like this. One is going like this, another one is going like this. No, they are continuous. They do not cross, do not intersect. So option D, show direction of the feed. Yes, it shows the direction of the feed is correct. Like this one now, it shows the direction of the feed. Are we together? This shows the direction of the feed. Option E, start from the negative charge. No, it always start from positive charge and enters toward the negative charge. This is the feed line. This is what we have. Something like this. As simple as this, very simple. So take note. It's always from positive and enter toward the negative. So A, B, C, and E are wrong. So the correct one is D. So the correct option is option D. Are we together? So moving on. Question 34 says, which of the following statement is correct about the circuit diagram? We have circuit diagram in figure 3.3a and that of 3.3b. So which is correct? If you observe the circuit diagram properly, you see that in circuit 3.3a we have two cells. So these two cells, the total EMF here is 2E, for instance. So if each of the cell is 1.5, then we are having total of 3 volt. So and here we are having the total EMF here, since they are in parallel, is the same thing as E. So meaning the total current, total EMF here, total voltage here is 1.5 volt, but this here is going to be 3 volt. And remember that voltage is the pushing force that pushes the electrons out, and the more the voltage, the more will be the flow of the current, and therefore it will result into a brighter bulb. Are we together? When the key is closed, that is when you switch on. So let's look at the option. A glows longer than B when K is closed in both. So they are saying that if you switch the two bulbs on, A will glow brighter than B. Is that true? No. A glows longer, not even brighter, longer than B is wrong, because here the two EMF here, the T voltage here pushes electron, assuming if the bulb here needed 0.6 amp, for instance. So this 0.6 amp is supplied at the same time by the two voltage here, by the two cells here, right? Each is contributing 1.5 volt, 1.5 volt. So and therefore it will make it to what? To exhaust in a short period of time. Compared to this particular one that are in parallel. So each will share the amount of current that will be needed by this bulb. As a result, it will last longer than A. Are we together? So that is wrong option. Option B. B glows brighter if K is open. If K is open, what does it mean? That is off, so it's wrong. The only way this bulb will glow is when we close the key. Are we together? So option C. B goes dim if K is closed. B goes dim if K is closed. No, I've already explained that one in option A, right? That B will last longer because the voltage here are supplied individually, they share the supply of the current that needed by the bulb. so it will last longer. It will not dim as soon as in a short period of time. Option D, the magnitude of the current applied in figure 3.3a is greater than the one in 3.3b. That is correct, because the more the voltage, the more the magnitude of the current. And in 3.3a, we have total voltage to be 2E, assuming E is 1.5 volt, therefore we have 3 volt. But in B, we have only 1 volt, which is what? E. And if it is 1.5, we only have 1.5 volt. So as a result, we have lesser current flowing in B than in A. Are we together? So that should be our correct option from what I'm seeing. But let's see the option E. Option E says the total voltage in 3.3A is higher than that in 3.3B, which is also correct. But I will choose D because D has a significant effect, right? A significant observable effect, like the brightness of the bulb compared to just mere the number of volt. And remember that number of volt is what led to the amount of the greater magnitude of the current that flows in 3.3A. Is that understood? So I took my time to explain this because it's very important for you to know the effect of batteries when arranged in series and their effect when arranged in a parallel. Are we together? So the correct option here is option D. We can also say option E is correct, but remember that the correctness of option B is what makes option D. The correctness of option E is what made option D to be correct. If the voltage is high, like here, 2E, then the magnitude of the current supply will also be high, leading to what? A brighter bulb. Are we together? So the correct option is option D. So question 35 says, a current of 0.3 amp was passed through a copper voltmeter and deposited 3.5 by 10 raised to the power minus 2 gram of copper on the cathode. Calculate the time taken for the copper to be deposited, given that the electrochemical equivalent of copper is this amount. So remember the Faraday's law of electrolysis. So here, given that the amount of current I is 0.3 amp, then we are given that the mass deposited M is 3.5 times 10 raised to the power minus 2 gram, and we are given that the electrochemical equivalent Z is 3.3 times 10 raised to the power minus 4 gram per coulomb. We are looking for the time T, right? So remember the first law of electrolysis, that is M, right? That is M is equal to ZIT. Is that correct? So we are given that mass is 3.5 times 10 raised to the power minus 2 is equal to electrochemical equivalent is 3.3 times 10 raised to the power minus 4 multiplied by the current, which is 0.3 multiplied by time. So that gives us 3 point. Let's make T subject of the formula. We'll make T subject of the formula. Okay, let's say 3.5 times 10 raised to the power minus 2 is equal to, multiply this to this, that should give us 0.000099 multiplied by T. From here, I can say divide both sides by 0.00099 divided by 0.000099. This one cancel this. Therefore, we have our T to be equal to 3.5 times 10 raised to the power minus 2, all divided by 0.000099. When you do that, that should give us, what? 3.54 times 10 raised to the power 2 seconds. Times 10 raised to the power 2 seconds. So the correct option here should be that should be 3. You have 3.14, 3.54, but raised to power minus 1, 3.54 raised to power 2 seconds. So option E is the correct option. Are we together? So we are going to stop here in today's class. In our next class, we'll continue from question 36. Thank you for your time and thank you for watching. God bless you. If you are new to this channel, please ensure you subscribe to give me some more visibility. Thank you. God bless you.